on yet?
I do, sir.
All right, just to let everybody know, we'll be recording this session. If you have any questions during the presentation, you can put them in on the chat panel on the right, and we'll try to answer those at the end of the presentation. So today we're going to discuss ultrasonic meters. The title of the presentation is what does the future look like? So we're going to talk about some of the diagnostics or some of the new enhancements and new features that are available with the next generation of ultrasonic meter. Eric, I guess the volume's okay. Everybody can hear me fine?
It's perfect, Joel. Thanks.
Okay, so here's the agenda for today's presentation. Just a brief introduction, who is SICK. We're going to kind of review some of the traditional ultrasonic diagnostics and of course go into some of the new or extended ultrasonic diagnostics that are now available and talk about some of the new technologies that are now exist in the next generation ultrasonic. I, like everybody else, is probably, I am broadcasting from my home office. I wanted to take a photo so you can see this is what where I am at, my laptop, and then I actually have a demo meter here on the right side that I'll be accessing during the presentation, so I can, at times, I can kind of show you where these new technologies, new features exist in the software on the meter. So SICK has a broad portfolio in the industries, mainly dealing with automation, factory automation, logistic automations, and of course the process automations where the ultrasonic meters exist. Just to kind of go through some of the technologies that we go into, SICK has sensors and for presence detection, in industrial safety analyzers for like emissions, and of course flow measurement, which is what we're going to be concentrating on today. Also, SICK has sensors and industrial integration systems and motion control sensors, also in the identification and measuring industry. And of course, we're always looking for new businesses to get into. So let's kind of start out by talking about some of the traditional diagnostics. I selected 5 of the, kind of one of the major traditional parameters for diagnostic purposes. These include the automatic gain control, signal to noise ratio, acceptance rate, speed of sound, flow profile, and symmetry. These have been around for a long time, since the meter was first developed, and of course it continues to be used because that's a good basis of doing our diagnostics. Let's talk a little bit about automatic gain control. Again, we're not going to spend a lot of time on this, but I kind of wanted to show you, some of the existing diagnostics and sort of what's new down the road. If we look at the meter that I'm connected to, you see here's your automatic gain control diagnostics, your acceptance rate, your speed of sound. These are, again, our live values from the demo meter. Here's your signal to noise ratio, and of course your profile and symmetry is in this diagnostic box here. You can also, one of the things that is kind of new with the software is you can also look at a 3D illustration of what the flow profile is doing. As you can see here, the red indicates that that's the majority of where the flow is going through. If I create some kind of blockage in the flow conditioner, you'll see how the turbulence starts going up, the profile changes, and then you'll see where now the red is mainly to the top of the 3D profile, and you see now that most of your flow is going through the top of the pipe. So you can see the changes that occur in this illustration. The automatic gain control has to do with the signal being received, and depends on the pressure, the meter size, and any specific dampening influences like the gas composition. A higher automatic gain control value usually indicates that it's a weaker signal. If we take a snapshot of that diagnostics that we just saw on the previous page, you'll see that, you know, this is your gain levels that you're indicating. Once these gain levels increase, it could be an indication that you have some contamination in the line, some buildup in front of the transducer, or possibly some liquids in the line. Signal to noise is basically the ratio between the signal energy and the noise. It's an indication of good acoustic quality. In the signal to noise diagnostics, on the values page, you'll see here where you have a certain ratio between the signal and noise. Anytime that gets below 30 decibels, you probably want to investigate to what's causing that signal to noise ratio drop down, which is usually an indication of some kind of interference or possibly some buildup in front of the transducers. Acceptance rate, or performance as it was known in the classic meter, is the ratio between the measurement signals and the signals being transmitted. In other words, if I send out 100 signals between a pair of transducers and I'm able to transmit those 100 signals without any rejections, then my acceptance rate is 100%. So this is a good way of kind of gauging the measurement plausibility as it's indicated there, or how many of the signals that I'm transmitting are being received on the other side. Obviously 100% is ideal, but it doesn't mean that you always have to have 100% acceptance rate. As you see here, our alarm limit is set to approximately 75%. Speed of sound is an independent measurement value specific to the gas composition's pressure and temperature. It's indication of the quality of the signal. If we look here, we see that in this example, our speed of sound is 1347, 1348, 4847. The speed of sound being calculated by these individual paths should all be within 2 feet per second of each other. If it's not, it's again an indication of something that's interfering with the signal going back and forth and causing the transit time to change, and should be investigated. And again, flow profile and symmetry is a reflection of the flow distribution from the top to the bottom of the pipe, as we saw in that example earlier. You know, whenever you have a block flow conditioner, it disturbs the flow coming through the meter, and then causes, potentially could cause some accuracy in the meter. So as we see here, that diagnostics is a quick way of identifying whether you have a good profile or not. Is my indicator inside the box? If it is, then you probably can be assured that you have a good flow profile and good symmetry in your meter. So all these are some of the traditional diagnostics that still exist in the next generation meter. But what's new? What's coming down the line, or what is already in existence in the meters? The first thing I want to talk about, excuse me, is the condition-based indicator. This is a new extended diagnostics that's available on a 4-path or an 8-path meter. Condition-based indicator is an additional diagnostic indicator based on a diametrical virtual path. Now, If we look at a 4-path meter in this example, as you know, here is one pair of transducers. Here's a second pair of transducers, third and fourth. So this is a 4-path meter. We are sending sound waves downstream and upstream between these two, or this pair of transducers. And we're measuring the transit times downstream and measuring the transit times upstream. And we're calculating our average velocity on the 4-path. What SICK has done in this next generation of meter is we now have something called the condition-based indicator. One of the things that we discovered by redesigning the transducers, we're able to actually measure the signal going from path 2 to path 3, as you see here in this illustration. So now we can measure the signal going between this cross-sectional area and this one here. So in essence, what we have is a virtual path that can measure the velocity through the center of the pipe. Now, as everyone that has these meters out in the field knows, if you have a 4+1 ultrasonic meter, you know, you can do some things with the 1-path compared to the 4-path. So this particular 4-path meter that we're seeing here can give you some of the same diagnostics that that 4+1 meter gave you in the past. So the CBI factor is a calculated, in other words, we're comparing, as you see the formula there at the bottom, we're comparing the 4-path average gas velocity to the 1-path using this virtual path, and we can come up with any deviations. As we can go in a little bit deeper, as you know, the 1-path has a higher change whenever the flow profile changes compared to the 4-path. So you can take advantage of that inside the software, as we see here. I'll close this out, and you can see if we go to our warnings page, you can see here where your CBI value is indicated, and you can set up a tolerance so that you can alarm off of that virtual path before maybe the 4-path actually gives you an alarm by doing that comparison. So that's one of the new diagnostics that's available. It's also available again on the 4-path. There's no additional hardware required. This is automatically, when you buy a 600 XT 4-path or 8-path meter, this feature is already in there with no additional hardware needed. And this is, of course, due to the latest generation of ultrasonic sensor and also a new sensor head design. So we'll talk a little bit more about that in a minute. Another thing that's available is this new installation setup that's in the commissioning wizard. So if we go back to our meter, click on our commissioning wizard and scroll over to the installation page, one of the things you'll see here is on this installation page is you have some new selections here. So this installation page wants you to tell the meter or tell the software what's included in this meter run. In other words, do I have a flow conditioner upstream of the meter? Do I have 2 flow conditioners, one upstream and one downstream, because this is a bidirectional installation? Do I have a pressure regulator or control valve up or downstream of the meter? Is this meter located downstream of a separator or some kind of D-high unit where possibly I might have liquid present inside the meter if those fail? So this is how you set up the meter. Now, this being set up has to do with the solution wizard, which is another feature that's updated in the meter. And let me get this back to green. So the solution assistant that is available now, I'm going to create an alarm here with this meter. Excuse me for a second. So if we go back to our diagnostic page here, we see now that we have a failure with the meter. So what you can do now, whenever you log on to the meter and you see that you have a failure with the meter, what you can do is you can click on the exclamation mark up here, or it may be a warning. You can click on that and it'll take you straight into the warnings page. And then you see up here on the top left, you have a button that says Start the Solution Assistant. So you can click on that and the solution assistant goes through some fuzzy logic. This is to help assist the technician out in the field to try to determine what might be wrong with the meter. So you see here, if I click on this, it says there's a 100% chance that there's an electronic defect. So if you click on this, the state of the diagnostic data indicates a hardware failure. Either the transducer or the electronics board has a fault. Then it goes through some proposed actions to correct that. And again, this is to kind of assist the technician out in the field to try to determine what the problem might be. So if we go back to here, again, you start the solution assistant. And again, here's some examples of some of the proposed actions that may come up. You may have dirty, depending on what alarm is set, you may have some just block flow conditioner or dirty transducers, or in this case, a failed electronics or transducer. Or in this case, it'll tell me, hey, Joel, plug the cable back in. So this is how the solution assist can help the tech out in the field. And again, this is something new, new diagnostics that's available. Archive diagnostics, there's also this is also available going back to this meter here. You see, here's our archive diagnostics. The archive diagnostics goes through and gives you the whole history of any events, errors that occurred, any warnings that occurred in the meter since it was plugged in. I can zoom in on a specific area, such as here, and look at this date, these particular dates, and then I can also zoom in even further, and I can see here's a warning that occurred, and if I click on that yellow arrow, it comes down here to the bottom, and it tells me that my CBI limit was exceeded on that date and time. So I have a whole history of archive diagnostics that I can look at, much similar to the archive diagnostics that you can download, but this kind of gives you a quick access to this information if you're trying to look at for one specific day that something may have occurred. If you double click on the screen, it'll take you back to the original view. So those are some of the new diagnostics that are available. You can also use this historical data to trend fingerprints with the meter. And again, that's for a later discussion, but there's some added diagnostics that can be done with that. Some enhanced or additional features that are available to the technician out in the field. Again, the new transducer design that we talked about earlier. In addition to the new transducer design, along with new electronics, you get better signal to noise or noise immunity with the new transducers and electronics that are now in the XT meter. There's a testing that was done. There's a little snippet down here on the bottom right that kind of shows some of the testing that was done, or an excerpt of some of the testing that was done with a meter, an XT meter installed 8 pipe diameters upstream of a pressure regulator with a pressure of 580 and a differential of 87 psi, flowing at approximately 28,000 cubic feet per hour. We see that the traditional classic meter performance failed down to 0, but you see where the new XT meter continued to operate and show flow measurement even under these extreme conditions. So again, sensor along with the new electronics gave us better noise immunity. You also have power-in technology available. Because of the low consumption of the ultrasonic, the SICK ultrasonic meter, you can actually run this off of a battery. So if you ever get a power failure or your fuse blows for some reason, if you opt for the battery backup, you will be able to continue running. Now, depending on how much I/O you have or you're using in the meter will determine how long that battery will last. But as you can see here, you know, an 8-pack meter will last approximately 1 week with all the I/O active. And of course, as you see here, as you go to the right, depending on how much I/O you're using, if you're only using your frequency outputs on a 4-pack meter, you can last up to 1 month off that battery. One of the things that does occur, though, is when you switch over to run off the battery, you know, the measuring rate reduces, your 485 Ethernet and other options are deactivated, but you always have frequency output and discrete outputs, and all your logging is still active inside the meter. Fingerprint enhancement is another one that's available. Real quickly, you're capable of creating diagnostic fingerprints from the commissioning data or from data that was recorded at the flow lab during calibration. Another option that you have now is extended calibration. This is an option to extend the lower and upper calibration ranges for better rangeability. Extending the range will optimize operations during seasons of high or low demand dominations. So in other words, during the winter, you may have high demand, so you flow very high. During the summer, you may have very low demands. In the past, you've had to get a device that can measure the lower flow rates. By extending the lower calibration range, you might be able to do that with just one XT meter. And of course, the XT now has the internal pressure and temperature sensor. The integrated pressure and temperature sensor is used for automatic corrections due to geometry and Reynolds effects. So in summary, condition-based indicator, or CBI, the virtual path, measures the velocity to the center of the meter and compares it to the average velocity of the main meter to evaluate meter performance. Enhanced commissioning wizard and solution assistant. In conjunction, those two features allow the solution assistant to evaluate resolutions to errors or warnings that occur in the meter. The archive diagnostics is a quick access page to view events and data logs and evaluate you know, anything that may have occurred during a specific date span. New transducers and electronics, along with calculating the CBI, the transducers and electronics have up to 12 decibels of better noise immunity. Extended ranges can provide flexibility in designing of the meter and meter runs. And of course, the integrated pressure and temperature sensor that is now mounted on the meter body of the XT meter provides live pressure and temperature values for corrections related to pipe expansion or Reynolds number effects. You know, this is a lot of data that's available in the meter. So yeah, at any time, if you need assistance with getting all that data and getting it out and sending it to your acquisition or possibly up into the cloud, SICK does have a system integration group that can help you with those solutions. Also, as everybody's aware, in the last 6 months, business has changed. You know, a lot of people working from home. Distancing has become an issue when related to field services. So SICK also does have virtual services that are available. We've actually done a couple of commissionings virtually, as they say, to assist customers in commissioning their meters, also in doing repairs and also some training. So those are some of the new technologies and new features and diagnostics that are available in the next generation ultrasonic meter. Thank you. I think my time is up. I think this was allotted for 30 minutes. Is there any questions, Eric, that came up?
Hey, yeah, Joel. Let me just start off here. I'll try to do these as they came in. The first question is, how low can the extended flow go with the extended calibration range?
I'd have to look at the numbers. I don't know if there's some of the sales guys out there online, but I believe it's down to half a foot per second, much less than a foot per second. I don't know if there's any one out there that actually has the numbers. Again, there's a presentation that's available for that, but I know you can get down to some very low flow ranges. Of course, there is some, you know, when it's calibrated at the flow lab, there are some things that have to be adhered to, some procedures that have to be adhered to. But I know that you can get down to half a foot per second if needed, I believe is toward the lower range.
Okay, great. Just for all of those in attendance, I want to point you to Joel's email address. I know that we're running up on time and we do have a number of questions here. So certainly if you have to drop off and you're unable to get your question answered, please feel free to contact Joel. But if you have time, Joel, and you can stay on the line, we have a few more I'd like to ask you. Sure. So the next question is, can you monitor the internal PT and TT that you recently mentioned with Modbus?
Yes, that is a Modbus register that is available. So if you want to monitor that, you can.
Okay, perfect. I'm not sure what the attendee was referring to exactly in this next question, but they ask, for how much time is that data available? We might want to ask them to email you with their specific question on that one.
As far as the data on the, if you're talking about the archive diagnostics, we have a meter back at the shop that was first, we used it for remote connections. It was installed in 1990, or I'm sorry, I'm dating myself. It was installed in 2016, if I'm not mistaken. And previously, when I've logged on to that meter, it gives me data back to 2016. So I've yet to really be able to answer that question. I know that that data is there for a long time. As you saw in this meter, there was data back to 2018. Sorry.
Sure.
So if that's what you're referring to, that's how long, it's a long time, let's put it that way.
Great. Next question is, are these features for new meters only? Can older meters be able to see any of these additional enhancements?
No, that's a good question. Some of the new enhancements are available if you do a gateway upgrade. There is there is an option to take the existing electronics off of, it's called a gateway electronics. We're taking the whole electronics and mounting it on an older meter. Now you're going to use the classic 600 meter body along with the transducers, and you mount the new electronics. And you don't get all the features, but you get like the solution assistant, you get a lot of the diagnostics available, like the archive diagnostics. And of course, you have some additional I/O that's available, onboard Ethernet for one. You don't get all the features because you're using the older transducer, so you don't get the CBI. There is a write-up. I was looking for it before this presentation. Unfortunately, I didn't find it, but there is a write-up that kind of shows you what is available if you upgrade to the gateway.
Great. We've got two more that we can probably get through here quickly. The next one is, will the meter calculate theoretical SOS for comparison purposes to measure, and is that exposed via Modbus?
Unfortunately, right now, and I can't talk a lot about what, again, I know this presentation is, what does the future hold for the ultrasonic? I can't really talk about what other things are being developed, but right now, the only way you can calculate speed of sound like you have in the past, and you can do some comparisons, but as far as doing live comparisons, that's not available currently, where you can do live comparisons.
Okay, great. And the last one here, how do you perform verifications on the internal pressure and temperature sensors?
There really isn't a way to calibrate that pressure and temperature sensor. It's more just for the meter to use that information. A lot of times you will get errors if the meter senses a failure. It probably does that by looking at I'm not really sure exactly how it does it, but there are some internal features that monitor the temperature and pressure internally. There's no way to calibrate those, so that's why we don't say that you can use that for, volume corrections or anything like that. It's mainly to measure the body temperature and the pressure in the line for those specific corrections that we saw in the presentation.
Great. Well, we've gone over quite a bit here, Joel. I just want to remind all the attendees that those of you customers who were in attendance today, your names will be entered in a drawing for two random drawings for $25 Amazon gift cards. Those should be announced by the end of the week. Thanks, everyone, for joining.